When the sky turns into a hunting ground, a predator takes the stage. Not just an air defense system, but a legend of aerial warfare. Feared, respected, and talked about around the world. This is the S-400 Triumph, the shield of the skies, capable of taking down anything that flies. The Russian S-400 Triumph isn't just an air defense system. It's a symbol of military dominance and cutting-edge technology. Designed to detect, track, and destroy everything from stealth aircraft to ballistic missiles, the S-400 can strike targets up to 400 kilometers away with pinpoint accuracy. Its advanced radar, rapid deployment, and multi-target capability make it a top choice for countries seeking powerful deterrence. Whether seen as a guardian of skies or a geopolitical disruptor, the S-400 commands attention on the global stage. In a world of rising tensions and evolving threats, this system is rewriting the rules of aerial warfare. The V-2 is the world's first ballistic missile, developed in 1936 to 1942 in Nazi Germany. Its technologies became the basis for the post-war development of missile weapons, including Soviet and American programs. The S-400 Triumph air defense system is considered one of the most modern and effective in the world. Its development history traces back to the era of World War II and represents a logical continuation of decades of advancement in Soviet and Russian air defense technologies. During World War II, the Soviet Union did not yet have specialized surface-to-air missile systems. The primary focus was on anti-aircraft artillery, which, however, proved to be of limited effectiveness against large-scale aerial bombardments. The experience of the war highlighted the urgent need to create more advanced air defense systems. In the 1950s, the active development of the first Soviet SAM systems began. One of the first was the S-25, Berkut, created to defend Moscow. This was followed by the S-75, Dvina, which gained worldwide recognition in 1960 after it was used to shoot down an American U-2 spy plane piloted by Gary Powers. In the following years, more mobile and accurate systems, such as the S-125 and the long-range S-200, were introduced into service. A major breakthrough in air defense came in the 1970s and 1980s with the development of the S-300 family. These systems were capable of intercepting not only aircraft but also cruise missiles, and later ballistic missiles. Different modifications were developed for the ground forces, S-300V, and for air defense forces, S-300P. It was based on the technologies and experience of this era that work began on an even more advanced system, the S-400. In the 1990s, despite Russia's difficult economic situation, work began on a new generation of SAM systems intended to surpass their predecessors in range, precision, and versatility. The goal was to create a system capable of effectively countering modern threats, including stealth aircraft, hypersonic targets, and ballistic missiles. Thus, the S-400 Triumph project was born. The S-25 was a stationary, bulky system, but for its time it was revolutionary. It could engage high-altitude targets, including high-speed bombers. More than half a century has passed since then, and each new system has been a response to evolving threats. Following the S-25 came mobile systems like the S-75 and S-125, and later the more versatile S-200 and S-300. The S-300 marked a major turning point. It was the first to combine the capability to intercept both aircraft and ballistic missiles. Initially, it was planned to modernize outdated C-200 installations for this. but decided to create a new system. However, the project was rejected by the State Commission due to the high costs and inability to counter the threat of cruise missiles. In the late 1980s, there was a need for a complex that could hit fast-flying targets at a distance of up to 400 kilometers. Thanks to what the development program was revived under the code name Triumph. It was supposed to create a system that could hit long-range aircraft, as well as cruise missiles and stealth aircraft. The development was carried out by the scientific and production enterprise Almaz, named after academician Rasputin. On August 22, 1991, the Soviet government approved the Triumph program. But the collapse of the Soviet Union brought development to a standstill. On February 12, 1999, the first demonstration launch of the S-400 rocket took place. Over the next 4 years, a new Russian anti-aircraft missile system was tested. On the 28th of April, 2007, by a decree of the Russian government, the Triumph system was put into service. And in August of the same year, the 1st Division and the S-400 command post entered combat duty in the Moscow region. The S-400 Triumph is the logical continuation and pinnacle of engineering evolution. Unlike the other countries in World War II, we now have the capability to defend against these advanced missile threats. The S-400 is a highly sophisticated system that can track, intercept, and destroy multiple targets, including ballistic missiles, aircraft, and drones, all within moments of detection. The S-200 is an older surface-to-air missile system designed to engage aerial targets at long distances. It has an effective range of up to 200 kilometers and can hit targets at altitudes of up to 40 kilometers. Developed in the 1960s, the system was primarily used to defend against high-altitude threats such as strategic bombers. Despite its age, the S-300 remains a relevant system for defending against aerial threats at medium and long ranges. It has a range of up to 150 kilometers and can engage targets at altitudes of up to 27 kilometers. The system is effective against aircraft and cruise missiles, although its capabilities against ballistic missiles are limited. The Panzer S-1 is a short-range air defense system designed to protect against low-flying targets such as missiles, helicopters, drones, and artillery shells. Its range extends up to 30 kilometers, and it can hit targets at altitudes of up to 15 kilometers. The system uses both missiles and cannons, allowing it to perform effectively in environments with heavy electronic interference and against fast, low-signature targets. Its high mobility makes it ideal for protecting convoys, installations, and battlefield assets. The Tunguska is another short-range system meant to defend against low-flying targets. It has a range of 8 to 12 kilometers and can hit targets at altitudes of up to 3 kilometers. This system combines the capabilities of a missile system and anti-aircraft artillery. Tunguska is effective against helicopters, aircraft, drones, and cruise missiles. The S-400 is the most versatile and powerful system in Russia's air defense arsenal, surpassing both the S-300 and S-200 in range and in its ability to counter more complex threats such as ballistic and hypersonic missiles. It offers high mobility and can be integrated into broader air defense networks. In contrast, the Panzer S-1 and Tunguska specialize in close-range defense and are effective against small, low-altitude targets. But their range and engagement capabilities are significantly more limited compared to the S-400. The first combat use of the S-400 surface-to-air missile system took place on November 26, 2015, when Turkish Air Force fighters shot down a Russian military aircraft. In response to this incident, Russia took decisive steps to bolster the air defense of its assets in Syria. Specifically, one S-400 system was deployed to the air base in Syria, where it was immediately put on combat duty. The system was quickly delivered to Syria and deployed for active service. The S-400 provided protection for Russian aviation and ground assets, as well as expanded the capability for surveillance of the air situation over considerable distances. The system is capable of detecting targets at a range of up to 600 kilometers and engaging them at a distance of up to 400 kilometers. This move significantly enhanced the safety of Russian military personnel and aviation involved in the counterterrorism operation in the Syrian Arab Republic. In addition to training exercises and serving as a security guarantor, the S-400 has been actively utilized in the Special Military Operation (SMO) in Ukraine. According to reports that emerged in November of last year, the Russian armed forces successfully employed the guided missile of the S-400 system with an active radar homing head during operations in Ukraine. A key role in this was played by the A-50 airborne early warning aircraft, which worked in tandem with the S-400 system. The S-400 missiles were equipped with new warheads, enabling the successful neutralization of Ukrainian air targets during the special operation. In peacetime, this system is primarily used for monitoring the movement of airborne objects, including civilian aircraft, providing situational awareness and early warning. The S-400 is deployed at strategically important sites, such as near major cities, industrial centers, and military bases. Periodically, exercises are conducted with personnel, both in field conditions and on simulators. This is necessary to maintain the readiness of operators and to test the operational performance of the system. In summary, the S-400 is deployed not only for combat operations but also plays a vital role in peacetime air surveillance and protection, ensuring the safety of critical national assets and personnel across a wide range of situations. The system's capabilities extend far beyond defense, offering both deterrence and operational flexibility. The S-400 Triumph surface-to-air missile system is a high-tech air defense system based on the integration of modern radar, navigation, computing, and communication technologies. A key component of the system is its multifunctional radar stations equipped with phased array antennas (PA). A PA is an antenna array electronically controlled to instantly change the direction of emission without mechanically rotating the antenna. This solution significantly reduces the time required to detect and track airborne targets, increasing the likelihood of a successful intercept. Additionally, the system's radars operate across multiple frequency bands, ensuring resistance to a wide range of electronic countermeasures and enabling effective detection of targets with diverse radar signatures, including low observable and high-speed objects. The missile guidance in the S-400 is based on a combined control system. Primary navigation relies on inertial systems with high-precision correction using radar data, ensuring stable target tracking at long ranges. The missile seeker heads integrate active or semi-active radar channels with infrared guidance, allowing the missile to adapt to changing combat conditions and effectively counteract active jamming and enemy concealment measures. The system's computing infrastructure consists of powerful digital processors and specialized data processing algorithms capable of analyzing large volumes of information in real time. Automated decision-making systems based on artificial intelligence minimize reaction time, optimize missile allocation to targets, and ensure effective coordination of all subsystems within the complex. Communication within the system and with external units is implemented through secure data transmission channels featuring multi-level encryption and anti-jamming measures. This enables operational information exchange with other air defense systems and command centers, forming a unified airspace management network and enhancing coordination. The system's mobility is ensured by specially designed highly mobile wheeled chassis equipped with automatic missile loading and control systems, allowing rapid redeployment and occupation of new combat positions without loss of combat readiness. In manufacturing the S-400, advanced materials are widely used: aluminum and titanium aluminum alloys, as well as composite materials that provide the necessary combination of strength, lightness, and corrosion resistance. Precision machining technologies, electronics assembly using automated production lines, and robotics ensure a high level of quality and reliability of the system's components. Externally, the S400 is similar to the S300 PM2, but the Triumph's technical capabilities are significantly higher than those of its predecessor, primarily due to new computers, radars, and missiles. The S-400 anti-aircraft missile division consists of two batteries. The radio engineering battery includes the 55K6E Combat Control Center based on the Euro 5323 truck, as well as the 91N6E radar detection system with a panoramic radar with anti-interference protection operating in the decimeter range on the chassis of the Minsk wheeled tractor plant, MZKT 7930. The launch battery can contain up to 12 transport launchers, as well as a set of 30 C6E technical support equipment. The anti-aircraft missile system can be equipped with radar stations for detecting aircraft with radar stealth technology. For example, Gamma D or Opponent G, as well as various electronic intelligence systems, including 1RL-220V. The S-400 can use different types of missiles, including the 40H-6E, with a maximum launch range of up to 380 kilometers. The 400s can take control of an entire air defense position area at once, combining various anti-aircraft missile systems and giving them orders to hit targets, including using older systems. In addition, the S-400 actively cooperates with reconnaissance aircraft, for example, the A-50 long-range radar detection and control aircraft, and fighter aircraft, whose range exceeds the affected area of any missile defense system. As the troops joke, "The best means of air defense is our tank at the enemy airfield." As on the S-300, the launch of missiles on the S-400 is carried out from vertically raised pipes of the transport and launch container with the help of a gas catapult. The missile defense system is ejected from the launch container up to a height of 10 to 15 meters, after which the control rudders deploy the missile on a preset course, and it rushes to the target. The vertical launch ensures that targets are fired within a 360-degree radius without turning the launcher in the direction of fire. Thus, thanks to the combination of innovative technical solutions, the S-400 represents a multifunctional, highly automated, and adaptive system capable of effectively protecting airspace from a wide spectrum of modern threats, including aircraft, cruise missiles, and ballistic missiles. In mere fractions of a second, the S-400 missile system neutralizes airborne threats with surgical precision. Designed for strategic air and missile defense, the S-400 Triumph is capable of engaging up to 12 targets simultaneously within a radius of 400 kilometers. This engagement envelope enables a minimal number of systems to effectively establish a multi-layered, high-density air defense shield over a vast operational area. A full S-400 regiment consists of 8 battalions, divisions, each comprising 12 transporter erector launchers. In practical terms, this equates to nearly 400 ready-to-launch interceptors, each capable of neutralizing a unique target within a 5 to 10 minute engagement window. These targets can range from tactical aircraft and UAVs to cruise missiles, ballistic missiles, and even hypersonic threats, creating a saturated defensive barrier often referred to as a kill net. The system's kill chain is nearly instantaneous. Once a target enters the radar field, acquisition is handled by multi-band radar arrays capable of tracking stealth, low-flying, and high-speed objects. The system's command and control C2 center receives real-time telemetry on target azimuth, altitude, speed, and trajectory. Fire control algorithms process this data and issue engagement orders to the appropriate TL. From detection to launch to intercept, the entire process is measured in seconds. A defining feature of the S-400 is its advanced discrimination capability. The system is equipped with radar and signal processing units designed to identify real threats amidst a background of electronic countermeasures, chaff, and decoys. Thanks to high-resolution target identification algorithms and frequency-agile radar technology, the S-400 can distinguish genuine threats from false positives with exceptional reliability. The system's resilience to electronic warfare is a result of its layered, network-centric architecture. It can integrate multiple radar types, including 91N6E Big Bird Surveillance Radar and 92N6E Gravestone Fire Control Radar, and operate in coordination with other systems such as the S-300 or Panzer S-1. This creates a robust information fusion framework that enhances situational awareness and survivability under contested conditions. Mobility is another key operational advantage. The S-400 is designed for rapid deployment. A complete battery can be repositioned and combat-ready within 10 to 15 minutes. This tactical agility allows for dynamic repositioning in response to changing threat vectors and enables temporary deployment in forward or austere environments. Interestingly, the S-400 retains the physical appearance of its predecessor, the S-300. This was an intentional design choice known as legendation, a strategic deception measure aimed at denying visual identification by adversary ISR. Visually indistinguishable from the older system, the S-400 makes it difficult for enemy forces to assess its capabilities or determine the level of threat it poses, thereby complicating their targeting and engagement strategies. In summary, the S-400 represents a leap in integrated air defense capability. It combines precision strike, rapid responsiveness, high target discrimination, EW resilience, and strategic ambiguity into a single unified platform, one that plays a pivotal role in modern layered defense doctrine. The S-400 Triumph surface-to-air missile system is capable of countering nuclear missiles of medium and short range, including ballistic missiles with nuclear warheads, thanks to several key technical features. From the moment a missile is launched, multifunctional radar stations with phased array antennas detect the heat signature and flight parameters of the target at long distances. Once the target is confirmed, the system continuously tracks its trajectory using high-precision processing algorithms that allow forecasting the interception zone, the missile's atmospheric reentry point, and the estimated impact area. Based on this data, the command center makes the decision to launch interceptors, determining their number and interception tactics for maximum effectiveness. The interceptors are launched from mobile launchers and begin their flight using inertial navigation with subsequent corrections based on the complex's radar data. During flight, the interceptors employ combined guidance systems. On the initial and mid-course phases, control is maintained by the inertial system with corrections, while in the final phase, active radar or infrared homing is activated, ensuring precise target acquisition and engagement. As the interceptor approaches the ballistic missile, it either detonates the warhead at a safe distance using a fragmentation warhead or destroys the target with a direct hit, resulting in the destruction or neutralization of the nuclear warhead. Afterward, radar systems continue monitoring the airspace to confirm the kill and detect any subsequent threats. In case of a failed intercept, a follow-up salvo is launched. However, it should be noted that the S-400 is not a specialized system for intercepting intercontinental ballistic missiles, ICBMs, and is primarily designed to combat tactical and operational tactical missiles. For protection against ICBMs, more specialized missile defense systems with enhanced interception capabilities at higher altitudes and speeds are used. The S-400 Triumph surface-to-air missile system is in service with Russia and has been exported to several foreign countries. The primary operators of the system today include Russia, China, India, Turkey, and Belarus. In addition, active negotiations and contracts are underway with countries such as Saudi Arabia, Algeria, and Serbia. Thanks to its versatility and high effectiveness, the S-400 has become one of the most sought-after air defense and missile defense systems in the world. Modern versions of the S-400 have received significant upgrades in radar equipment, expanded missile types, and improved resistance to electronic warfare and jamming. The new missile types can engage targets at ranges up to 400 kilometers and at altitudes ranging from a few meters to 30 to 40 kilometers. The system's reaction time has been reduced thanks to a high degree of automation and the use of advanced data processing algorithms, increasing its effectiveness against modern aerial threats. In May 2025, the world once again found itself on the brink of a large-scale conflict. Tensions between India and Pakistan peaked following a series of terrorist attacks in Kashmir, which the Indian side blamed on groups allegedly supported by Islamabad. In response, India launched Operation Cinder, a series of precision strikes on militant camps and infrastructure located in Pakistan-administered Kashmir and Punjab. This marked a turning point. Within 24 hours, Pakistan retaliated with a massive assault. However, India met the threat fully prepared. The Indian military deployed Russian-made S-400 systems, alongside its own Akash missile systems and Israeli Harop loitering munitions, to repel the attacks. Yet the cornerstone of India's defense was clearly the advanced S-400 Triumph surface-to-air missile systems. At that time, for combat-ready S-400 regiments had already been deployed across the country, equipped with powerful radars and long-range interceptor missiles. This enabled India to establish a dense anti-missile shield over its critical regions. The S-400 demonstrated remarkable effectiveness. Within seconds, the system detected incoming missiles and enemy drones, tracked their trajectories, and launched interceptors. Of the 27 missiles fired by Pakistan, 21 were successfully intercepted and destroyed mid-air. Several drones were also neutralized by medium-range defense systems and fighter aircraft. But the S-400's role went beyond just intercepting threats. Its effectiveness changed the very course of the conflict. The system prevented key military installations from being taken out of action, preserved the operational capabilities of the Indian Air Force, and enabled military command to respond swiftly with retaliatory strikes. Moreover, the mere presence of such an advanced defense system served as a powerful deterrent. Pakistan refrained from further escalation. The S-400 proved to be not just a weapon, but a technological shield that protected India at a moment of grave danger. Alongside the modernization of the S-400, a more advanced system, the S-500, Pramati, is under development. The S-500 is intended to become the main element of Russia's air and missile defense for the coming decades. It possesses significantly expanded technical capabilities. Its radar stations can detect air and space objects at distances up to 600 kilometers, with a maximum interception range reaching 500 kilometers, far surpassing the capabilities of the S-400. The system is designed to engage a wide range of targets, from aerodynamic objects such as aircraft, helicopters, and drones to ballistic missiles of short, medium, and partly intercontinental range. Special emphasis is placed on countering hypersonic vehicles and low-orbit space objects. The S-500 can intercept targets at altitudes ranging from several hundred meters up to about 180 kilometers, enabling effective destruction of objects both in the upper atmosphere and near-Earth space. Its interceptor missiles reach speeds of around 7 kilometers per second, significantly faster than S-400 missiles, allowing engagement of high-speed and maneuvering targets. The S-500's radar operates in a multi-band mode with high resistance to interference, enabling simultaneous tracking of 10 to 12 targets and firing on 10 to 16 targets at once. The system is built on modern digital technologies and artificial intelligence algorithms, allowing for rapid processing of large data volumes, automatic prioritization of targets, and efficient coordination with other air and missile defense systems, including lower-tier assets. The S-500's high mobility is achieved through modern wheeled chassis and automated launch and reloading systems, enabling quick repositioning and prompt response to emerging threats. Thus, the S-500 represents a fundamentally new level in the development of Russian air and missile defense systems, greatly expanding the range of interceptable targets and enhancing protection of strategically important assets. This system can effectively counter new types of threats, including hypersonic missiles and near-Earth space objects, making it indispensable amid the rapid advancement of military technologies and the increasing complexity of aerial combat environments. Overall, while the S-400 remains a reliable and modern system for regional airspace defense, the S-500 sets new standards by combining air defense and missile defense functions with extended capabilities to operate against current and future threats. The S-400 Triumph isn't just an anti-aircraft missile system. It's an absolute beast among air defense weapons. It can detect, track, and destroy anything that flies, from fighter jets, ballistic missiles to even nuclear warheads, regardless if they tried to hide beyond the horizon or cruise through the stratosphere. The S-400 is a real shield that makes the sky over the country untouchable for any enemy. With unmatched range, target versatility, and insane precision, the S-400 isn't just good, it's a seriously badass piece of weaponry. People fear it, people respect it, and it damn well gets the job well done.